13.2, verify trig identity. So let's do this worksheet. Much like last time, I just want to start you guys off with this reminder of how to do all the basic identities we use here. So tan is sine over cosine. Cosecant is 1 over sine. Cotan, it's 1 over tan, but I prefer to use cosine over sine. Secant would be 1 over cosine. Then we get to the trigonometric identities. So sine squared plus cosine squared equals 1. And then, so remember, this is the key to everything. If you know this, it makes the rest easier. So if you know sine squared plus cosine squared equals 1, which is just a squared plus b squared equals c squared. And to get sine squared, you just move cosine squared over. So it's 1 minus cosine squared. And then to get cosine squared by itself, you just move sine over. 1 minus sine squared x. These are a little more complicated ones. This makes life easier if you know them, but they're not necessarily required. 1 plus tan squared equals, it's 1 plus tans and the codes go together. So this would be secant squared. It's 1 plus tan and the codes go together, so this would be cosecant squared. Then this is like a fancy version of this. Since I know secant squared equals 1 plus tan squared, that's what right here, 1 plus tan squared. It's like the backwards version of the other one. So again, how do I remember those? I always remember that it's 1 plus tangents squared, and the co's go together. So it'd be cotan squared with cosecant squared, which means tan squared go with the non-co, which would be secant squared. Okay, so now again, we're doing more advanced stuff here. So now they want me to add these two functions here. So the probably easiest way to add them is you want to get the common denominator. So this has a sine. I want to get a sine on this one. So you multiply both top and bottom by sine x. And that gets us 1 minus, I'll write it separately for now, over sine squared x over sine. Now later on I'll just skip past this step because now they have the same denominator. I can combine them and I get 1 minus sine squared over sine of x. Now remember, the signs here do not cancel. This is 1 minus sine. It has to be exactly the same to cancel out. So I'm stuck here. Besides the fact that I could change this to 1 minus sine squared is cosine squared. So I get cosine squared x over sine of x. That's pretty much where I'll stop. Now there's lots of ways I could write this. I could write cosine times cosine and make cosine over sine cotan. But in general, this is fine. Look at the same thing here. I want to add these, but they have different denominators. So, common denominator. Multiply this side by sine over sine, because it doesn't have the sine. Multiply this side by cosine over cosine. Right, because I'm trying to get the same denominator here. On this side, I'll get cosine squared. Since they're going to say the number, I'm going to write them all over I'll write them all together. I'm going to skip this middle step I had wrote last time. Cosine x, sine x. And on this side, I'm going to have cosine squared. Sine times sine is sine squared. So I get that. And now you have this. And now, can you go any further? Well, cosine squared plus sine squared is 1. So I get 1 over cosine x, sine x. So I can leave it like that. Or if you want to be adventurous about it, 1 over cosine is, like, you can kind of write like this if you want. And like this. And that would be cosecant times secant. Actually, secant times cosecant because cosine's in front. So it's be cosecant, so be secant, that'd be cosecant. But again, either way is fine. I just want you to add them, so I'm fine stopping. Just to show you how you could go further if you wanted to. And we also want to talk about how to factor. So the best way to factor is kind of ignore the sign. So pretend this is like 1 minus x squared. So when you factor it, you're going to get 1 minus x. Whoops. It's the difference of two squares. So it's 1 minus x, 1 plus x. So in this case, it'll just be like saying 1 minus sine x, 1 plus sine x. Same thing here. This is like saying a squared minus b squared. So it's just going to be a minus b, a plus b. So this will be cosine x minus sine x, cosine x plus sine x. Alright, we're getting more advanced with the tricks with the factoring and stuff. Over here, again, much like the first one, the best way to do this for me is just ignore the signs for now. So this is just essentially saying x squared plus 3x plus 2. You want to factor that? Well, two things multiply to get 2, but add to get 3. So I know some people do this thing. I never got that. It is 1 and 2. So 1 times 2 is 2. 1 plus 2 is 3. So I'm going to get x plus 1, x plus 2. And then now I just put the signs in. Put the signs back. Sine of x plus 1 sine of x plus 2. And now it's factored. Right here, multiply by the conjugate, then simplify. So this is like it's like a more advanced trick. So I want you to multiply by the conjugate. So remember, the conjugate is the difference of two squared things. So if you have this, the conjugate would be a minus b. So over here, I'm looking at the denominator. Make it 1 plus sine of x. 1 plus sine of x. And now you multiply it. Now the top, just leave it. It's cosine x times 1 plus sine x. I won't even simplify. I'm going to leave it like that. Bottom of the difference of two squares. That's why we do the conjugate. Right? It's like this. So I'm going to get a squared minus b squared. Or in this case, I'm going to get 1 minus sine squared. And why is that so important? Because 1 minus sine squared is cosine squared. So I get this. And this is also why we don't simplify the top. Because stuff might happen. That. And now, remember I said about how you simplify it? These are exactly the same. There's not a 1 plus cosine here. These are both just cosines. I can simplify them. And get 1 plus sine x over cosine x. That's how that one's done. Verify each equation as an identity. So now we're doing trig identities. Like, this is kind of the main part of this lesson. Now the key thing to remember when you do trig identities is that this equal sign is kind of like an imaginary wall. So what you want to do is try to make one side like the other side. So you can do this a couple ways. You can work on one side so it looks like the other side. Or you can work a little bit on this side and a little bit on this side until they match. What you cannot do is add, you can't like add across both sides. It's not an equation like a normal one. Like if I gave you this, you can't just go, oh, let's subtract 1 from both sides. It doesn't work like that. We're just trying to verify these are right. We're not trying to prove anything. We're trying to verify these are right. So the general idea is take the more complicated side and try to simplify it to look like the less complicated side, the more simplified side. So here, only thing I could really do is multiply it out. So it's a difference of two squares, but you just multiply it out if you're not sure. So we get sine of x plus sine of x minus sine squared. Again, you can skip this step because it's a difference of two squares. So I get that. And then what's 1 minus sine squared? Cosine squared. See? And these sides match. That's how you verify. Right? They should match. They are going to match. I'm letting you know this is identity, verify it. These guys show the work to get the answer. So like this is the answer, is the work here. Not the fact that they're the same. I know that. Showing the work is the answer. The same one here. I got 10 squared theta equals 1 minus cosine squared over cosine squared. So there's like an imaginary wall here. You can work on one side. Let's work on this side. Now, there's lots of ways you could do this. You might think about splitting them. 1 over cosine squared minus cosine squared over cosine squared over cosine squared. Or, what's 1 minus cosine squared? Sine squared. So you can get sine squared x over cosine squared x. And sine squared over cosine squared is just 10 squared x. I guess this shouldn't be x, it should be theta. There we go. Just match the other side. There you go, and that's how you verify. Again, there's lots of ways to verify. That's one way I did it. If I wanted to, I could do it a completely different way. I could do this. I could split it and go 1 over cosine squared minus cosine squared over cosine squared. If I simplify this, this is the same thing as saying secant squared minus 1. And secant squared minus 1 does equal tangent. You're like, why does it equal tangent? Because don't forget the rule. 1 plus tan squared equals secant squared. So if you subtract the 1 from both sides, it's the same thing. So again, I'm just trying to show there's lots of ways to do this. Lots of ways. I would have done it the first way I did it, by the way. That's the easiest way to do it. This next one, I got cotan plus tan equals secant squared over tan. I'll tell you right now, this is probably one where I'm going to work on both sides, maybe. Not totally sure. I always like to work on the more complicated side. And for me, that's actually this side. There's a secant over tan. I don't like having the tan in the denominator. So remember the trick I used to do? If it's on the bottom, you can flip it to the top by doing its reciprocal function. So it's the same thing as saying secant squared theta cotan theta. Now where does that get me? Well, these are still not the same. So I gotta work a little bit more. So lots of ways to do this. let's say secant squared is, I'm trying to decide how I want to do this. I'm just gonna go with my gut. So I'm gonna do it a little more complicated than I probably would do normally, but I'm gonna make it work. So this is 1 over cosine squared theta. I'll come back and I'll do a shortcut version later. And tan is cosine over sine. And if I simplify that, I just get this cosine theta. Oh, these reduce. So I cancel that. I get 1 over cosine theta sine theta. Now that doesn't match this side, so I gotta work on this side also. So let's do this. Cotan is cosine over sine. Tan is sine over cosine. Now notice how this is one thing and this is two things, right? This is a binomial. This has two terms, this has one term. So what I'm gonna do here is I'm gonna combine these two terms. So I'm gonna multiply this side by cosine over cosine. Multiply this side by sine over sine. Over here I'm going to have cosine squared, sine squared. And on the bottom I have cosine theta, sine theta. Right, because they have the same denominator, so I just combine them. And then cosine squared plus sine squared. That's just 1. So I get 1 over cosine theta, sine theta. And those match. Right, so this one's I did it the longer way where I had to kind of work on both sides. I worked on this side, so I got to a point where I felt like I couldn't go any further. Then I worked on this side, and I had to go to a point where they matched, and then I was done with this one. So that's one way to do it. Now again, the key thing is you can do this lots of ways. I'll do a little faster way this time. So another way you do it, if you know the pro advanced moves, is that you can move this up, make it cotan. So I get secant theta. Square theta, cotan theta. Now what does secant squared equal? If you remember from over here, secant squared equals 1 plus tan squared, right? 1 plus tan equals secant squared. So I could rewrite this as 1 plus tan squared theta, cotan theta. Then you can distribute, and if you distribute, cotan times 1 is just cotan. Tan times cotan, remember, they're reciprocals of each other. They cancel each other out. If you have tan and cotan, right, they cancel, you just get 1. But this is, but I have tan squared, so actually tan squared and cotan, only 1 cancels out. And I just get tan theta. So that's like the shortcut version of doing it. So again, if you know those trig functions, like all of them, it makes it you can go by much faster than if you just have to go like sine, cosine all the way. The next one, tan squared equals secant squared plus 1, secant squared minus 1. Again, imaginary wall right here. Tan squared, I mean, I can make it, what was that, secant squared minus 1. But I have this right here also. Like this, to me, this is a more complicated side, so I'm going to simplify this. Now, it is the difference of two squares, if you notice, so you could just go secant squared minus 1. I'm going to take a little first in case people are not sure. I'll just multiply it out. I get secant squared theta minus secant theta plus secant theta minus 1. These cancel. I get secant squared theta minus 1. Now from here, again, they don't match, they make a match. Well, what do I do next? It's ugly secant. I could rewrite secant. Secant, as we talked about right here, is 1 plus tan squared. So I'm going to get 1 plus tan squared minus 1. Well, now these cancel out. You just get tan squared. Something like that. Again, lots of ways to do this. That's just one of the ways. Next one. Tan squared cosecant squared equals 1 plus tan squared. Again, I always say this, but there's so many ways to do this. You turn everything to sine and cosine. You can work on one side or the other. I'm going to work a little bit on both sides, I think. So like 1 plus tan squared, I know is secant squared. Right? It's always 1 plus tans, and the cos go together. So 1 plus tan squared goes to secant squared. Over here, I have tan times cosecant. I'm going to try to simplify this. Tan is sine squared over cosine squared. And cosecant is 1 over sine squared. Well, now the sine squareds cancel. I just get 1 over cosine squared, which is secant squared. So these two sides match. Now again, if I wanted to, it could have been a little cleaner. I could have not even done this right here. So many ways to do this. And I could just been like, hey, I'm here. 1 secant squared equals 1 plus tan squared. And then go, these match. So it's any way you want to do it. There's lots of ways to do this. Next one. So I have a 1 on this side, so probably not touching the one side. And over here I have cosine squared plus tan squared cosine squared. So again, so many ways to do this. The first thing I think of, since I see 2 cosines, I think of factoring out the cosine. So I get cosine squared theta, and I get 1 plus tan squared theta. Like that. Right, so factor out the cosine. Since it's a cosine, then you took it out, so I'm only 1 there. Tan squared cosine, this gets me tan. 1 plus tan squared is secant squared. I'm not sure why I canceled it out. It's just secant squared. Right? 1 plus tans, the cos go together. So 1 plus tan squared is secant squared, and I have cosine squared here. Well, cosine and secant are opposites, so they cancel each other out. The reciprocals, I should say, they cancel each other out. You just get 1. So you verified it. Let's do some more. The next one right here. Kind of the opposite of the one we just saw. The first thing, so this is just cosecant, but you can't do much. On this side, I see there's a cotan out there, there's a thing there. So let's distribute. So I get cotan squared. Cotan plus times tan, they cancel each other out, the reciprocals of each other, so you just get 1 equals cosecant squared. Well, cotan squared plus 1, remember the rule, is cosecant squared. Right, again, if you have all the trig ones down, it's so much easier because there's like little shortcuts. Like, oh, it's already done. That equals that. Cotan squared plus 1 equals cosecant squared. The one right here. So again, I think the left side looks more complicated. I really can't do much with the right side. So what they do with this? They don't cancel each other. Sine goes with cosecant. Sine and cosecant, they cancel. Sine and cosecant cancel each other, not sine and secant. What I can think of is rewrite things. Remember, I like to keep sine alone. Change everything else. So let's change secant. Secant is 1 over cosine squared times sine squared. Well, I can combine it to be 1 over sine squared cosine squared. What's sine squared but cosine squared? That is tangent squared. You know what 1 plus tan squared equals? Secant. Right? So knowing those trig functions, again, those are so helpful if you have those trigonomic identities down. Let's do some more. This one's a good one. Well, it's a 1 on that side, so not touching that side. And then look at this side. This is like a classic example where I just go, hey, let's just change everything that's not sine and cosine. So sine is sine. Secant, I don't know what that is, so let's change it. That's 1 over cosine. Cotan, cosine over sine, let's change it. And look what happens. Everything kind of cancels out. Cosine, cosine cancel. Sine and sine cancel. I just get 1, which matches this side. Next one, now look at that. That looks complicated. 1 minus cosine over 1 plus cosine equals cosecant minus cotan squared. That's a scary one, right? I might have to work on both sides on this one at some point. But to start off, I think I'm just going to do this. So don't just square both of them. I'm telling you what's going on here, right? This is cosecant theta. Oh, that's ugly. Cosecant theta minus cotan theta times itself, cosecant theta minus cotan theta. Right? It's not you don't just square both things. You have to multiply by itself. So now here we got distribute. So I get cosecant squared. And for once it's not a different 2 squares, you actually just gotta multiply it. Minus cotan cosecant minus cotan cosecant plus cosecant squared. Let me clean this up. I can add the middle 2, so it looks like this. Cosecant squared theta minus 2 cotan cosecant plus cosecant squared. Cotan squared, sorry. It's like that. Again, this is a tough one. What can I do next? Well, all this has is cosine. I'm like in the weeds here with cosine and cotan. So let's do this. I know cosecant is. Cosecant is 1 plus cotan squared. So if I do that, I could add the cotans together. And I get 1 plus 2 cotan squared theta minus 2 cotan cosecant. This is still a mess. Then the one on this side, I probably still have to work on that side. I probably would change everything to sine over cosine. I might do that even before. You know what, honestly, let's go back. Since row time. Oh, I don't want to go that much back. Let's go back to here. From here, since I noticed everything here is cosine, I'm just going to rewrite everything. I'm going to skip us. I'm going to try this instead. So let's rewrite. Cosecant is 1 over cosine. Sorry, 1 over sine squared. Minus 2 times cotan is cosine over sine. Times cosecant 1 over sine. Plus cotan cosine squared over sine squared. That looks a little nicer. Right, notice they all have the same denominator. Even this, that's sine squared on the bottom. So if I combine it all, I get this. 1 minus 2 cosine plus cosine squared over sine squared. Right, so I did all of that. I got to here and I tried something, it didn't work. And I was like, let me try something else. Let me rewrite it in terms of sine. So in terms of cosine to sine, so I just rewrote them all. I got this, right? Again, this is probably the hardest one we've done so far. What do I do next? Couple things. I'm actually running out of space here. The bottom I could rewrite. Notice that my answer only has cosine. That's a sine. That doesn't match. What could I rewrite sine as? 1 minus cosine squared. So I'm actually bringing it right here because I'm just running out of space. I have this now. 1 plus 2 cosine x. And that should be theta, but I'm running some put x right now. All over 1 minus cosine squared x. So I have that. So we get here. And actually there's a small typo. I forgot to bring over the negative. It should be a negative. It should be 1 minus 2 cosine x. There we go. So we're here, right? We're almost done. I know it was a lot of work. So it's a little fast recap, right? So I saw this and I was like, okay, this side is more complicated. So let's simplify this side. Now remember, it's square 72 multiplied by itself. So I did that and you got down to here. I tried something that didn't work. I was trying to rewrite stuff and I was like, wait. All we have is cosines. So we should put everything sine and cosine. So cosine squared equals 1 over sine squared. Cotan is cosine over sine. Cosecant is 1 over sine. Cotan is cosine squared over sine squared. Then you notice, wait, I can combine them all. They're all the same denominator. So you do that, you get here. But then again, your answer has 1 plus cosine at the bottom. So I have sine squared, so you have to change that. So what does sine squared equal? 1 minus cosine squared. Put all together, you get here. So you're like, okay, what's next? Next is we factor. If you look at the top here, you could factor that. If you look at the bottom here, that's the difference of two squares. That's like 1 minus x squared. So the bottom is the easy part. It's just 1 minus cosine x, 1 plus cosine x. Right, so I have 1 minus x squared. 1 plus x, 1 minus x. The top, let's write it over here so you can see a little better, is 1 minus 2 cosine x plus cosine x squared. So it's like saying 1 minus 2x plus x squared. Right, so we got to factor this. What two things multiply, you get 1, but I have to get blah, blah. It's going to be 1 minus x, 1 plus, 1 minus x. That's it factored, right? 1 minus 2x plus x squared. It's 1 minus x times 1 minus x. That gets us that. So if we put it back, it'll be 1 minus cosine x times 1 minus cosine x. These cancel, and you get 1 minus cosine x over 1 plus cosine x, which is the answer. I know, long, ugly one. Next ones, they're all going to kind of be worse now. So I have this here. 1 minus 2 cosine squared over sine theta cosine theta equals tan theta minus cotan theta. So you can work on either side. And actually on this one, I think it's probably a little easier if we work on the right side actually. Notice how the right side's 2 terms and the left side's only 1 term. So it's your choice, you can do any way you want. I think I'm actually going to work on the right side. I think it might be a little easier. Let's just come with experience, right? So tan is sine over cosine. Cotan is cosine theta over sine theta. So the trick you always want to use. If you have 2 terms and you have 1 term, I'm just going to combine the 2 terms. A lot of times that's a lot easier than separating the 1 term. So I'm going to combine these 2 terms here. So I need a common denominator. Multiply this side by cosine over cosine. Multiply this side by sine over sine. So I'm going to get sine squared theta over cosine theta. Sorry, sine squared theta minus cosine squared theta all over cosine sine. Like that. Now look at the top here. So let's compare. I do have the bottom correctly. It's sine squared cosine squared. And on the top one, I got sine squared minus cosine squared. But that's not what they have here. They have only cosine. So I got to change the sine squared. So I got to make that, what does sine squared equal? 1 minus cosine squared. Then you could add it. So now on top I have this. So I get 1 minus 2 cosine squared theta over cosine theta sine squared theta. And that's that one. Next one. So I have tan here, sine over cosine. And over here I have secant cosine. So I'm working with this side. I'm working with this side here. Now I don't like fractions, so I'm going to change cosecant. Remember the trick to flipping it is that you make it the reciprocal function. So reciprocal cosecant is sine. So I'm going to get secant theta sine theta. And now I'm going to change secant, so who likes secant? Let's make that cosine, so it's 1 over cosine times sine, which gets me sine over cosine, which is tan. Just gonna put tan theta. So like that. So you can see most of these aren't too terrible, and then you got the disgusting one right here. Most of them aren't too bad though, hopefully. So let's go to the last page here. Cosine equals sine times cotan. Like, this is a joke. Change cotan. Right, I always write a more complicated side. This is a more complicated side. When it's stuff like this, I always like to keep cosine as sine and change everything else. So let's change cotan. So I'm leave sine the way it is over 1. Cotan is cosine over sine. Look at those cancel, you just get cosine. Easy. Over here I have all this and that. So again, negative cosine, I'm probably just gonna leave it alone. I can't get any similar than that. This side I actually gotta multiply it out. There's like nothing special here. You just gotta go, okay, sine times tan. This might be ugly also. Times tan theta. And then sine times secant. And then here, negative 10. And negative secant. So I get all that. I don't see where this is going. Like I don't have a good idea of how to simplify this. So I'm going to change everything to sine and cosine. It's like do my general rule. And all this fails is change it to sine and cosine. So I'm going to leave sine alone. I'm going to change tan to sine over cosine. So I'm going to have sine theta times sine over cosine. Plus the middle one here, and leave sine alone. I always like put over 1 so it's a little easier to see. Secant 1 over cosine. And now last two, tan is sine over cosine. And secant 1 over cosine. So I just changed everything to sine over cosine, right? Wasn't sure, changed everything to sine over cosine. But what do you notice right away? All the denominators are cosine. I can combine all the tops. So it's something like this. Cosine on the bottom. On top, this is sine squared. Plus sine. Minus sine. Minus 1. Like that. Right? So sine times sine is sine squared. This is just sine. That's just negative sine. That's just negative 1. And what happens next? Well, those cancel out. And I just get sine squared minus 1 over cosine squared. Cosine theta. You're like, that doesn't look like this. Now here's a trick to this one. There's a little bit of a trick here. This is negative cosine. This is sine squared minus 1. This is not cosine squared. A lot of people think that, right? Cosine squared is 1 minus sine squared. So how do I get from there to there? Well, I factor out a negative. Right? Remember those tricks we learned? You can factor out a negative and it switches this to 1 minus sine squared. Or you could say it makes this a negative, makes that a positive, and then you can rearrange it like that. This is just cosine, not cosine squared. 1 minus sine squared is cosine squared. So just so you can see, I'm going to write right here. So we have negative 1 times cosine squared over cosine. These reduce, and you just get negative cosine, which matches the right side. Right, so I mean, I took up too much space, but that was the general idea. So I was like, okay, I can't do anything here. How do I work on this side? Just distribute. Nothing fancy, just some good old algebra 1. So you get this, and then I just like, okay, what do I do next? Well, let's just, since it's kind of funky, let's just change everything to sine and cosine. Now I was able to combine the tops. These cancel out, I got to here. And I was like, that looks almost like cosine squared, but it's not. It should be 1 minus sine squared. So you have to factor out the negative, and you get this. That turns into cosine squared. Now these reduce. And I just get negative cosine. Okay, last couple. So I got secant minus tan, and I got 1 minus sine cosine. So you can work on either side. I'm always a big fan of this. Only if this has 2 terms and this has 1 term, it's easier for me to combine than it is to separate. Actually, in this case, I'm gonna do it both ways. In this case, separating is actually way easier. But I'm gonna do both ways just to show you. So I'll do it. I'll combine these two first. So I'm gonna rewrite it: 1 over cosine minus sine over cosine. I guess it's really easy either way. So I'm not gonna do. I can do both ways still. Hey, they both have cosine on the bottom, so you just combine it. 1 minus sine theta over cosine theta. And they work. So you can do it that way. Or you can do the other way. So the way I was going to do it, also think about it, is I could separate these two. That also works. So if you have this, the way you separate is that since there's only one thing on the bottom, you can put both of them. So it's 1 over cosine minus sine over cosine. So you can do it this way if you want. And then 1 over cosine is secant. And sine over cosine is tan. So it works either way. It works either way. So this one wants this one here. And this one looks disgusting. So I started this last one. This one looks bad. So I think I'm going to work on this side. I know this is 2 things I just said. If it's 2 things, I can't work on that side. I might have to actually work on both sides of this one. The reason I'm going here, because I see the secant, cosecant at the bottom. I don't like that. Don't like that at all. So I'm going to work on this side first. And I'm going to do is move those to the top. So I'm going to get something like this. Give myself a little space. 2 plus secant, cosecant. That looks ugly. And then remember, if I flip it to the top, you change it to the reciprocal, so it'll be cosine and sine. Right, so sorry about the weight there. Move this to the top, it changes the reciprocals of them, so cosine and sine should have theta, I'm just lazy. And then right here, 2 plus secant, that stays. And then what I do next is distribute. This goes to both of them. So I get 2 cosine theta, sine theta. Now over here, secant times cosine sine, those are the reciprocals of each other, right? Secant reciprocal cosine, that cancel out, you get 1. Cosecant reciprocal sine, they cancel out, you get 1. So I just get 1 here. So I get there, and I'm pretty much done. I can't do anything else. So what I'll do next is I'll actually work on this side. So normally I'll do it right here, but I don't really have space, so I'm going to do it down here. So I'll work on this side down here. So remember, when you square something, you got to multiply by itself. So sine theta plus cosine squared theta times sine theta plus cosine theta. And I just distribute. Sine times sine is sine squared. Sine times cosine is sine cosine. This one, I get sine cosine again. I'll write cosine sine just to talk about it. Cosine sine, I'll talk about that in a second. And then you get cosine squared. Now these two, they look the same, but one's sine cosine, one's cosine sine. They're exactly the same. This is the one that's actually improper. It should be in alphabetical order. So if this one should actually be cosine sine, it's the exact same thing. So this is actually sine squared theta plus 2 cosine theta sine theta plus cosine squared theta. So you get that. What do I do next? Well, hopefully you notice that there's a sine squared plus cosine squared. Right? And that's the main trig identity. Sine squared plus cosine squared is 1. So you actually just get 1 plus 2 cosine theta sine theta. And that matches that. And there you go. And that's the worksheet.